Let's see the problem trapping rainwater. Given n non-negative integers representing an elevation map where the width of the each bar is 1, width of the each bar, okay. Compute how much water it can trap after raining. So this is the example has been given. First wall height is 0, second 1, 0, 2, 1, 0, 1, 3, 2, 1, 2, 1. Okay. So and width of the this wall is 0 unit, 1 unit, sorry. So we have to compute how much water will be stored between the walls. The above elevation map is represented by array. In this case, 6 unit of rainwater will be trapped. See here, this green color is water 1, 1, 2 plus 3, 5 plus 1, 6. Just see the explanation. Here height of different wall has been given and we have to find out the maximum amount of water, how much it will be stored between these walls. So I will take in this graph format the walls. So what I will do, I will take two pointer from left side wall and right side wall. So at first say this will represent I, this will be J. So how will be water stored between two walls? See, if left side wall is 1, right side wall is 2, its height. So which wall is the deciding factor for storing the water? See here, maximum amount of water can be stored between both these two walls now. So whichever wall height is lesser, that is the deciding factor for how much water will be stored there. So here I will take two maximum height of the wall for both the extreme end. So here L will at first start with first 0 and here R will start from last, this will be 1. Okay, and now I will compare from both side. So here deciding factor will be whichever is lesser. Whichever side wall is lesser, that will be the deciding factor how much amount of water will be stored between the walls. So now at first see, right side wall maximum height is 1 and left side wall height is 0. So for now left side wall is deciding factor. From this side I will move right direction and from this side I will move to left direction. Okay, so first wall height I take at first for both. So for last wall, its maximum height is 1. Okay. And left side initial height is 0. So I will move to next position I. And I will update L accordingly. L will be now 1. Because L has to be taken the maximum height of the wall. Okay. So now 1. Now see, here water can be stored. If it's between any wall height whose height is 0, then water can be stored here. Because left side wall height is either less than or equal to right side wall here. So see, this height is 1 and right side wall height is also 1. But now there is only two walls here. So now come here I 0. So see now for height 1, this amount of water can be stored because right side it's already 1 height and left side is 1. Here water will be 1. Now we will move to next I. It will be updated to 2. But now see here, L is 2 and right direction wall is 1. So again we will have to move from right direction. So J will be updated to this and right side wall is now 2. Okay. Now again left side wall height is less than or equal to right side wall, 2 and 2 both. So we will move from left side. 1. See here 1. Here also 1 unit of water will be stored, because left side wall maximum height is 2 and here it is 1 and right side wall height is also 2. So here water amount will be updated to 2 unit. Okay. Now again we will move to next I. This is 0. So here also water can be stored for 2 unit. So total amount of water will be 2 plus 2, 4. Now next height 1. Here also 1 unit of water will be stored. So water amount height is now 5. Now I will go to this. Now its height is 3. So see, now from left side wall only we can't decide, because right side wall is now 2. It's lesser now. So I will move from right side wall now. So j equal to 1. See here 1 unit of water can be stored. So total amount of water is here 6. Next we'll go to j. This is 2. No amount of water can be stored. So total amount of water is here 1 plus here, say 1, 1, this was 2, 1 and 1. So total is 6. So this will be the answer. This is the maximum amount of water can be stored between the walls. Let's see the code. Let's see the code of this trapping rainwater. What I will do, I will take at first the length of this height n equal to height, sorry, length of height. I will take two maximum height of the wall from left and right side. So L and R are these two maximum height of the wall from left and right side. L will be first height. Initially I will start with first height, so height 0, and right will be last wall height. This will be n minus 1. Next I will take two pointer, no, I and j. I will be 0, j will be n minus 1. Next I will take one variable for storing water equal to 0. Now I will compare inside this while loop while I is less than j. I is moving from left direction now. Now I will compare the deciding factor. Whichever wall height is lesser, that will be the deciding factor for storing water. So if L is the left side wall maximum height and R is the right side wall maximum height. So if L is less than or equal to R, in that case water plus equal to left side wall minus current height. Actually we are moving from left direction. In that case L is the maximum height and height, this is the current height. Therefore L will be in the left direction and height In that case, L will be in the left direction and height will be in the right direction. In that case, only water can be stored and L should be greater than height. I will move I plus 1 and I will update L also. L will be the maximum height. In that case only we can subtract height now. Height I. We will update the value of L, maximum of L and next height. Because we are considering here for next height if we go inside this loop again. Else case can be else R is less than L, no need to write. In that case water will be R minus height J. I will decrease the value of J by 1 and I will update the value of R maximum with R and current height, next height. From right direction I will update R with R and its previous height J. Because in next loop it can be the case now we have to store the water maximum height. So R next R can be maximum. So I will update here. Total amount of water will be stored here inside water because I is less than J. Until I is less than J, then only this while loop will go. That means there will be complete traversal. When J is becoming less than I, that means it's not possible. So this is complete traversal. After that, we will return the amount of water. Just run the code. It's accepted. Submit.